So, we've been talking about ratios and proportions here. What we're going to look at today, we're going to start out with a little bit of a review of percents. Now remember, percents were really percent or out of 100. 48% means 48 out of 100. It's a ratio that's always comparing to 100. And as we were doing some of our calculations, if we were to ask you blank is 40% of 60, we set this up. 40% is 40 out of 100. Out of 60, well, blank is 40, so the missing number goes with the 40. Out of 60 goes on bottom. We would cross multiply and divide. 40 times 60 is 2,400. Divided by 100 is 24. Or we might be asked 30 is blank percent of 40. Now here we're missing the percent, but we're still going to start with it. It is blank out of 100. And now 30 is blank percent, so the 30 goes with that missing percent out of 40, so 40 is on bottom. And we cross multiply and divide. 100 times 30 is 3,000. Divided by 40 is 75. So that is 75%. Or we might be asked 45 is 90% of blank. Now we have the percent. 90% is 90 out of 100. 45 is 90, so 45 goes with the 90. We cross multiply. 100 times 45 is 4,500. Divided by 90 is 50. So 45 is 90% of 50. Easy enough, right? Look familiar? Yep. I just wanted to throw that out there now that we're doing ratio and proportion, that percents really are a proportion. That's all they are, is a constant ratio. We talked a little bit about yesterday about similar figures. Let's continue with that today. Taking these two figures here, you can see that one is just an enlargement of the other. Now I want to find the missing pieces here, x, y, and z. Well, first thing I would usually do is match up sides. Like I know the 4 goes to the 8, and this 4 goes to that 8, and the 24 goes to the 48. The x goes to 24, the 10 goes to y, because I asked. The 20 goes to z. Well, now I need to pick a pair that I know the length in both figures. There's actually a few of them here. Give me one of them.
24 to 48.
24 to 48. Sure, go for the one with the largest numbers. Yeah, it's always easy. So 24 to 48. Just kidding. You have the 4 to 8. Either the 4 to 8 or the 24 to 48 would work there. So, which variable do we want to solve for first? X, Y, or Z? Somebody said Z. So where's the Z going to go? Z goes on bottom because it's from the same figure as the 48. Now what's going to go on top of the Z? The 20 is the same side from the other figure. We shall cross multiply and divide, and we get that Z is 40. We'll do the same for X and Y. 24 over 48. Let's do X. Where's X going to go? It goes on top because it's from the same figure as the 24. What's going to go on bottom? Well, X is linked to the 24. So if we cross multiply and divide here, 24 times 24 divided by 48 is 12. X equals 12. You guys get the picture, right? And we even talked about three-dimensional shapes. like this. We can take a three-dimensional shape and let's say the sides on that increase. Let's say that this was 6 inches and now it is 15. And in this direction, we're going to call this, oops, I can actually name one of those probably, huh? We'll call this 25 inches. This one here we're going to call Y, and this will be 8 inches here. To find those missing dimensions, even though these are three-dimensional figures, we're still just looking at lengths. So the 6 matches up with the 15. We're finding X. X goes on top or bottom. Top, because it's in the same figure as the 6. And it'll match up with the 25. So now we can cross multiply and divide to get X must be 10. And then to find Y, we still got 6 over 15. Y goes on top or bottom? Bottom. And what goes above the Y? 8. Oops, other way. We're going to do 15 times 8 divided by 6 tells us that Y is 20. So we can still use this on three-dimensional objects. Now you do have to be a little bit careful. First of all, you got to be a little bit careful trying to draw out something like this, because I can cheat and just copy it and expand it, and you can't. Let's say that we are told that this had a length of 20 inches and is expanded to a length of 32 inches. But I don't want to know the length of the sides. What I want to know, if the area of this was 320 square inches, what's the area of this one have to be? It's not just going to be 20 to 32. Let's do a little background work and come back to that. Let's just take a square that is 2 inches on a side. Let's say we're going to expand it to be a square that's 5 inches on the side. What's the area of this one? 4 inches squared. What's the area of this one? 25 inches squared. Is that a 2 to 5 ratio? No, it's not. The lengths are 2 to 5, but the areas are 4 to 25. Not the same. This is a much smaller ratio than 2 to 4. Or 2 to 5 is like 0.4. 4 to 25 is like 0.16. Much smaller. But is there a relationship between them? If I take that ratio of lengths, 2 to 5, and I square the numbers, 2 squared is 4, 5 squared is 25. The ratio of areas is the square of the ratio of lengths. So if I come back up here, my ratio of lengths is 20 to 32. To find my ratio of areas, I need to square that. Now I could reduce that first if I wanted to 5 over 8, which would make it a little bit easier, but we'll just leave it as 20 to 32 just for fun. Yeah. 20 squared is 400. 32 squared is... No. 32 squared is 1,024. I can't believe you didn't know that. So then over here, now this was the ratio of lengths. This is now the ratio of areas after we square it. So we've got the 320. Where's that going to go? Top or bottom? On top. That's from the smaller figure. The smaller number. So now we cross multiply 1,024 times 320 divided by 400. 819.20. So the area of this is 819.2 inches squared. What do you think? Better than a sharp stick in the eye? So let's take a figure like this. And let's say that this, oops, that's not what I want to do. Let's say that this slope here goes from being 18 inches down to being 12 inches. And we know that the surface area of this was 90 inches squared. We want to know the surface area of this one. The ratio of lengths is 18 to 12. I'm going to reduce that to 3 to 2 just to make it easier. What, am I going to square that? Is this still an area? Even though these are three-dimensional figures, we're talking about surface area, so it is still an area. It's still inches squared here. So yeah, we are just going to square it. It'll be 9 to 4. Where's the 90 go, top or bottom? 90's from the 18. 18 was on top. So 90 goes on top. So we shall cross multiply and divide to get 40. Is square inches is the surface area of the other figure. Not so bad. What if we have an unusual figure like that? Get up here. And this time, we go from having a length of 20 feet to 12 feet. This one had a volume of 1,200 cubic feet. I want to know the volume of this one. Now my ratio of lengths is 20 to 12. Yes. My ratio of lengths is 20 to 12. I can divide by 4 to get a 5 to 3 ratio. Am I going to square that? Why would I cube it? It's volume. It's feet cubed. Yes. So 5 cubed is 125. 3 cubed is 27. So my ratio of volumes is the cube of the ratio of lengths because it's 3 dimensions now. Over here, the 1,200 goes on top. So it is 27 times 1,200 divided by 125. So 259.2 cubic feet. What do you think? Good stuff? Good. Well, I have got a piece of paper I'm going to hand out to you. It's going to be labeled page 250. And I'm going to have you do 1 through 16 all. Now the top of the page, the first several problems are just three-dimensional figures, but you're just finding lengths. They're ratios of lengths. The word problems at the bottom of the page involve you have to decide whether you're dealing with a ratio of areas or a ratio of volumes, and then adjust the ratio of lengths, squaring it or cubing it appropriately.